All right, let's actually code this. Class code. Binary search. Binary search. All right, let's copy. Let's see what we got. Yeah, let's copy lab 09, everything there to here. Let's do it recursively so I actually get everything. All right, okay, so let's go into source. We're gonna get rid of all that stuff. All right. So let's gvim source. Let's go ahead and do array search.hpp. If not defined, array search underscore hpp. Go ahead and define it. And if. Beautiful. Tab new source array search. We'll make that the CPP. We'll go ahead and include array search.hpp right up top. It's great. And let's go ahead and open up main. All right, we're not doing that. Whew. They get rid of that fast. All right. So hopefully that has everything set up. Let's go ahead and do make. Oh. Let's add the make file so the binary makes at least some sense. Array search test. Okay, good. We can make and run it. Beautiful. All right. Now, so first off, we need to come up with at least some type of array. We want to use integers for now, so life's easy. Yes? Okay. What numbers do we want? Hey, the ones on the board. 3, 4, 7, 18, 21, 45, 57, 83, and 100. Great. So let's go ahead and write linear search real quick. How do we want to do a linear search? Well, we probably want to return the index that the item exists. So int index of, we'll pass in the array, the size, and then of course the value. Oops. Go and comment this real quick. Return the index of val inside of array. Return -1 if not found. All right. Ooh, let me close this out because gvim's doing something weird. Did I not save that? All right. Apparently my comment got deleted, so let's go and fix that. Yes.
You have a question?
Mm-hmm.
Oh, I just want to ask, do you need like square brackets for each array?
Yes, I do. Thank you. Hold on. Return index of val and array. Return -1 if the item does not exist. All right, let's go and give it square brackets. Array.hpp. Oh, I put the comment right here. Whoops. That explains that. And then tab new source main. Excellent. Okay. So, see out. We'll say, we'll start with, what do we do, 57? 57 is at index of, passing in array. How many elements are in here? 9 and 57. All right. So we got that in there, index of, we probably should include array search.hpp. Let's see if I type that all correctly. Let's see what happens. Yep, all right. So we typed it correctly, but obviously it's not making any sense. So if we were to do a linear search, what would we do here? For loop. All right, so let me go ahead and int linear search int array int size, int val. Return linear search of, we're passing an array, size, and val. Perfect. All right, so for int I equals 0, I is less than size, I plus plus. If array sub I equals val, what do I return? Someone said it. I, yeah. And then if all that's wrong, we return -1. Okay. Good, at index 6. All right. So that's what we're used to. Let's look at binary search. Okay. All right, guys, let's go. All right, let's make it mid. All right. Int mid equals size divided by 2. Great. Beautiful. All right, we know the middle. For loop. Actually, yeah. Is this are we going to do a recursive algorithm or an iterative algorithm? Do y'all know what the difference is? Have y'all done recursion? Yeah. So is binary search recursive or iterative? Okay, technically you could write it either way, but which way do we think about it? Hmm? How do you think?
Unless you're going to send smaller arrays.
Let's do it recursive first. All right? When you're writing a recursive function, what's the first thing you write? Right, what? Okay, yeah. You want to always test to see if you need to get out. For example, if size is less than or equal to 0, return -1. Okay, because obviously it's not right. All right. If size equals 1, what are we going to return? Well, let's stop there. Let's stop there for now. I'm thinking ahead too much. So we have mid. Now what do we do?
Check the value that mid is equal to.
Okay. Yeah, if the values of mid, we're good to go. If array sub mid equals val, we return mid. Okay? Oh, min. Details, details. All right, if it's at mid, go and return mid. Okay, great. Now what?
Check if it's less than if the value mid is less than one value.
Okay, so if array sub mid is less than val, and we're going to do a good old else in here, so else, perfect. What do we do if it's less than val?
Then we need to take the upper half.
Okay, so we're going to have to do a binary search on, what'd you say, the upper half?
Yeah.
How do we send that to this function? Let me help you all out here, because the syntax here might be a little weird. And this will hopefully clarify things. Remember, this is actually a pointer. Good morning. What could we do?
Simplest way to create another array and look through, I guess, and assign the values to that will also take more time.
Well, hold on. I mean, I see what you're saying. So we got to think about this recursively. We're right here. We find out that this number is less than the 57 we're looking for. So we want to recurse, right? And do our check again. But what are we checking? We're checking this range right here. So how can we send this to our function?
You could just add x to the array,
Which is doing what?
moving down that many.
Right.
counted
So
sides.
we could, all right guys, come on. This is the trick. Array plus
That's gonna be mid.
mid, okay. So array starts here plus mid, zero, so that'd go right here. So we probably want to do mid plus 1.
So I guess this is just moving the memory
The-
address of the first.
Right, it's moving the pointer down. Correct, so we move the pointer down, yes.
Since array is the pointer, shouldn't it be dereferenced when you're trying to go in with all the checks for like array at point mid equals?
Yes,
Oh,
but they are being dereferenced by the solid brackets.
oh okay.
Yeah.
Oh, also, if
Here, let me make that a little clear in a comment. Remember, array sub mid is the same thing as the dereference of array plus mid. Same thing.
so it's not going to cause any simulation faults, like from you moving it.
Yeah, why is it not going to? Well, we know what the size is, right? So we're going to make sure we move within that amount. And dividing is truncating the remainder. So we should be good to go. Like if you had 1 divided by 2 is going to truncate to 0. So then 0 plus 1 will still be 1, so we're still okay. All right, what's the size?
Size minus minus 1.
Yep, minus mid, minus 1. And then we'll pass in val again. Okay. Anyone having questions about what I'm doing here? Definitely a different way to think about it, yes?
Can you explain again the binary search of parameters
So the parameters,
you're passing?
right, so we're passing in the array of integers, or it's actually a pointer to where an array of integers exists.
Okay.
All right, now here's the trick, and this may be helpful. This is an array of integers, right?
Yes.
This is a different array of integers. This is a different array, this is a different array. But the trick is, I'm pointing to where this array starts. So that first pointer is pointing to where the array begins. Okay? So we're going to point to where the array begins. We're going to tell you how many elements are in that array and what we're comparing against.
Okay.
If the size is less than or equal to 0, we're done, let's get out.
Yeah.
Find the middle. If it's equal to val, return mid, because we're done. Otherwise, we're going to call ourselves again, but instead of passing in the entire array, we're only going to pass the starting point of the array that we want to inspect, which happens to be array plus going down mid number of elements, which in this example on the board would go to 21, but we want to go down 1 more, so we add 1 here.
Okay.
The new size is going to be what's left, which is the size minus the mid minus 1.
And so if you wanted to find the other side, you just change what value, because that first parameter, it's taking your start point and just
Moving it.
adding to it.
Yep.
So that it starts. Okay.
If it's in the first half, you just change array plus mid plus 1 to just array, and the size minus mid minus 1 remains the same.
Yeah.
So,
Oh. That's cool.
All right, so we want to return this. Is this correct? Not quite, but we're going to leave it this way for now.
Okay.
Otherwise, what are we returning?
just change the array plus mid plus 1 to array.
Yeah, to array. And then now we're going to evaluate this, but with the size. Okay. All right, let's see what happens. Oh, it came out correctly. All right.
Wait,
We didn't
change the
mention what it was called.
Okay, good catch. Index at -1. That's not good. All right. There are different ways to evaluate this. The way I like to do it is std, cout, Let's see. First element array sub 0, because that's always available. Size equals, oh, I hate doing this with cout. All right, and then val equals val. Oh my goodness, okay. All right, let's see what happens. Oops, didn't like that. All right, probably because we should include IOStream. All right, first element is 3. That makes sense. The next one is 45. And then size is 0, size is 1, size is 0. Oh.
So it's returning negative 1 because size already is 0.
Yeah, so size is 0. When over there it was saying size is, oh, so size is 4, is that correct? When it's up here? 1, 2, 3, 4, that's correct. And then when the first element's 45 and it's these two guys, the size is 1, that should be 2. Uh-oh, there's our problem. Because size at that point needs to be 2. Size is 4, that's correct, 1, 2, 3, 4. So we have a sizing issue, and this is a problem with binary search. Because your size, yeah, trying to find your size can be a little weird. Well, let me see if I remember this, because it was up to 4, the mid should be this.
Yeah.
Yeah, let's see what's going on here. I put min again, that's okay. And we'll do type array sub mid equals array sub mid. All right, let's do it this way. View. So mid is 2, array sub mid is 8. Oh, okay, so it found a 4 divided by 2 is right here. That's correct. I went up 1. That's interesting. Okay, that's fine. And then what happened, unfortunately, is when it went down, mid minus 1, so we did not want to subtract 1 right here. Does that make sense? Because if mid goes up to here, 1, 2, 3, 4, 5, mid should be 4. 1, 2, 3, 0, 1, 2, 3, 4. Yep. Hopefully y'all see what the issue is. So you would think to subtract 1, but that's going to cause a different error. It's actually going to be okay this time. But we're going to stick with it for now. Yeah, so it's saying index 1. Why is it saying index 1? Right, we're changing the mid. So how can we quickly fix that? Let's do that error first, because that's a good one. How do we fix that? You can do it that way. We're doing it recursively. If it's in the lower part, is the binary search going to return the correct answer? Yeah, as long as you keep going down, right? Right. But if you go up, it's the problem when it's not going to return the right answer. But it's only giving you the mid of what's up there. So what you need to do here is add, yeah, you need to add mid. That way you keep track of it. Index 5, ooh, we're almost there. Plus 1, why would it be plus? Oh yeah, because it's, yeah. You're right. Because the mid is now over here. Yep. Silly off by 1 errors. All right. So we're almost correct. But let me pause here for a moment. Do y'all see how we define this recursively? Yeah, a second. All right. Okay, so the question is, why did we not subtract 1 from here? Well, this code is not quite correct. Let me see if I can make an example of this. I think if I put in 83, it's going to give me the wrong answer. Nope, it still gave me the right one. Because the problem, hold on a second. So you're doing array size. Oh no, size minus mid. That's actually correct, because you just want to cut off the top part and still leave down here. Yeah, so that's still going to give you the right answer. Not quite as efficient.
The 45 as well. Oh, the 45.
Yeah, so if we put in, yeah, so this is actually going to give you the right answer. Yeah, so if we did the 45, index 5, right? 0, 1, 2, 3, 4, 5. Perfect. Okay.
Dr. West?
Yes.
So with functions that are recursive,
Mhm.
does the recursion usually happen near the end, or?
So yeah, this is tail recursion. In general, you want it to happen towards the end. The reason for that is more about software engineering, because it's easier to read this way. You know, your base case is up top, you do your calculations, then you recurse. Not all functions are going to be that way. When we go to merge sort, you're going to have base case, recursive call, do your calculations.
Okay, would you say that that's for, like, I guess, special cases when you would have recursion like near the middle rather than the end?
I wouldn't say it's a special case, but you always want to have your base case up top, otherwise you are going to be very, very sad, and your code is going to break.
You mean the base function, right?
Yeah, the base case. When do you stop the recursive call?
Okay.
Okay, so this was the recursive way of doing it. How are we doing time? All right. There's also the linear way to do it. What you want to describe how you would do it? Not linearly, but iteratively. There's the iterative way of doing it. How would we do it iteratively? Where you have a for loop instead of calling yourself, or a while loop, or whatever loop you want.
We have nested for loops into each other when we wanted.
No, it's just you would have to know when to stop. Because you'd have a start, an end, and a mid. You do your calculation, then you would update them, and then you would do again, start, mid, end again, and you would keep changing those until either start and end were the same, in which case you return -1, or you finally found it at mid. I think it's actually messier to do it the iterative way. I think the recursive way is better for a binary search, programmatically speaking. But if you, for your lab, wish to do it iteratively, that is perfectly fine. There's a couple of gotchas with here, but I'm going to leave that for the lab, for when y'all do that, because I need to move on to sorting.